Hello guys, Paul McWhorter with TopTechBoy.com, and I've got a very quick lesson for you. This is a supplemental lesson to lesson number 2, and the reason I'm doing the supplemental lesson, when I was reading the comments after a lot of you guys watched lesson number 2, there was a little bit of confusion and I wanted to provide clarification. What was the confusion over? The confusion was over how to properly choose a current limiting resistor for your LED circuit to make sure that nothing is damaged when you turn it on. Okay, now I will say what I showed in lesson number 2 was correct. We got to the correct answer, 1,000 ohm resistor in series with the LED. That will make sure everything is safe. But as people were looking at it, they did not perfectly understand what I was doing. And then some people were arguing for a different approach. And then some people were arguing for an approach that was actually wrong. Okay, so I want everyone to more perfectly understand how I got to the 1,000 ohms. Okay, so let's start by saying, what is the purpose of a current limiting resistor? The purpose of the current limiting resistor is to ensure that you do not draw a current which will damage either your LED or damage your Arduino. And in particular, we don't want to damage the Arduino. Now, the Arduino R3, it could drive a lot more current from those digital pins, and so we typically used a 330 ohm resistor, and that was well within the tolerance of where you would never be worried about burning out your Arduino on the R3. Now, this is the thing about the R4. They dropped the current drive capability of the digital pins on the R4 down to 8 milliamps. So what could happen if we try to draw more than 8 milliamps? We could burn out our Arduino. So we've got to make sure when we're hooking circuits up that we don't try to draw more than 8 milliamps. Otherwise, we would damage the circuit. Okay, so let me show you our circuit and let's talk about this particular topic in a little bit more detail, okay? So from last week, what I was showing you was, I was showing you that this is the voltage supply. For the sake of that lesson, that was a digital pin on the Arduino, and then you come over and you go to your diode, you go through your light emitting diode, and then we put a current limiting resistor, okay? And then what the question was, what value should that resistance be? Okay, what value should that resistance be in order to ensure that you never drop, you never try to pull more than 8 milliamps, okay? What else do we know? We know that this was 5 volts that is coming off of the digital pins on the Arduino. And then what we know is we know that the maximum current, the I max that we want to try to draw is 8 milliamps. Okay, now what I did was said, okay, let's just put in resistance and we say V is equal to I times R. And then I said, let's just assume that all the voltage drops across the resistor. And so then what we could say is, well, that the resistance, let's divide both sides by I. The resistance would be the voltage divided by the I max. Okay, what did I do? I divided both sides of the equation by I, and now I have R is equal to V divided by I max. So then I say R is equal to V. We know what that is. 5 volts, and then I max is 8 milliamps, and then we change milliamps to amps, and so that's 5 divided by 0.008 because we're changing milliamps to amps. And then when I put that in the calculator, what I get is 5 divided by 0.008, and then I get 625 ohms. So if that resistance is 625 ohms, then there is no way that I could draw more than 8 milliamps. But then what people were saying is they said, wait, you've got a voltage drop across the diode, okay, and then therefore you're not going to have 5 volts across the resistor. You're going to have something less than 5 volts, and therefore you would do the calculation and you would get a much lower resistance, okay? You would get a much lower resistance because some of the voltage is dropping across the diode. Now, there's parts of that that are true, but there's parts of that that then leads you to getting a very dangerous value for the resistor. So what is true is the voltage as you go around your circuit, the voltage, the 5 volts, has to be dropped across all the different components in the loop. So you add the voltage drop of each of the components that is in the loop, and it will add up to your source voltage. And so what do I know? I know that the voltage source, which for us is 5 volts, is going to be equal to the voltage drop across the diode plus the voltage drop across the resistor. Okay, that makes sense. And so, you know, if I have 5 volts dropping across the resistor, I have 0 volts across the diode. If I have 3 volts across the diode, then I have 2 volts across the resistor. Okay, that part is true. And then what people were saying is, well, you know, you can have 2 volt drop across the diode, and so really there would be 3 volts across the resistor. And so what they're saying is that if you've got a voltage drop of 2 across the diode, then actually you're going to have 3 remaining to drop across the resistor, and therefore the resistance would be the voltage drop across the resistor divided by the I max, and then that is going to be 3 divided by 0.008, and then they're going to get, let's try that, they're going to get 3 divided by 0.008, and then they're going to calculate a 375 ohm resistor. And, you know, let's push things a little bit. What's the one closest to that? Would be 330 ohms. Okay, and that is what they are saying. All right, but now let's think about it. Can you say that you sometimes get a 2 volt drop across a diode? Yes, you can. But what you have to see is the current voltage characteristics of a diode are not linear. They are exponential, meaning a very, very small change in the voltage on the diode can cause a very, very large change in the current through the diode because it's an exponential. And so if you were saying, well, if I just put the diode in there and I put it at 1.8 volts, then I would have, I put it at 1.3 volts, I would be drawing 6 milliamps, and I wouldn't need a current limiting resistor because I could just run it at that voltage and everything's going to be okay. Well, what's the problem? What if you aren't right at 1.6 volts, but you have a little noise or a little error and you're a little bit more than that and you get a huge increase in current? Then you have possibly either damaged your diode or you have damaged your Arduino. So let's actually look at a typical current voltage. Let's look at a typical current voltage curve of a LED, of a red LED. What do you see? It's exponential. It doesn't change very fast at first, and then it just is off to the races and changes very, very quickly. Well, what do you notice? If you're doing your circuit analysis and let's say, let's plug in 2 volts for the diode, and you're saying, okay, we're going to plug in 2 volts for the diode. Well, if you have a 2 volt drop across the diode, what current is that diode going to be drawing? It is going to be drawing 45 milliamps. What if you design your circuit to draw 45 milliamps? What is going to happen? You are going to burn out your Arduino, or at least burn that pin out. And you could say, well, let's come down here and let's just do this circuit. Okay, let's do this circuit. I'm going to put plus, minus, and then I'm going to come over and I'm going to put a diode in my LED, and then I'm going to go like this. Okay, no current limiting resistor, and I'm going to run at 1.7 volts. And then at 1.7 volts, I am right at 8 milliamps, and everything's going to be okay. All right, but what happens if your circuit heats up a little bit or cools down a little bit, and this curve shifts a little bit, just a tiny shift, and very quickly you're up here at 20 milliamps. Okay, very quickly you are up here at 20 milliamps. And then what have you done? You have damaged your Arduino. Now, you don't want to damage the LED, and you don't want to damage the Arduino. So when you're doing this, you've got to see, well, which one is more sensitive? You know, if the LED is more sensitive, I'll design around its current handling capability, or if the supply is more sensitive, I will design around that. You want to design around whichever one has the lower current handling capability. Okay, well, most LEDs can certainly take more than 8 milliamps. So for the purpose of these lessons, what are we worried about? We don't want to burn out our Arduino. Okay, well, if 2 volts is not the right thing, what voltage do I put in for the diode? This is what you have to do. You have to say, those diodes, I don't know what they're going to do. I don't know what they're going to do. What I know is I don't want to burn out my Arduino. So I want what? 8 milliamps max. No, I better get out of your way because this is important. 8 milliamps max, no matter what. Okay, no matter what. I want 8 milliamps max, no matter what. Well, you see, I don't know what the voltage drop across the diode is going to be, because it could be down here at 1.65, or it could be up here at 1.85, and those little bitty changes in voltage have massive changes in current. What else can happen? An LED over time, now it's very unusual for the component to fail, but what if the LED failed over time, and what if it became a short, no voltage drop across it? Now, it's probably been burned out for some reason, something caused it to be burned out, but when it's burned out, if it fails as a short, what do you not want to happen? You don't want to then go and burn your Arduino out. So how do we do a circuit like this? Okay, how do we do a circuit like this? Okay, I'm not trying to do a circuit analysis. I'm trying to do a circuit design where I design for the worst case, and under the worst case, I don't want my Arduino to burn out. So how would I choose my resistor? Okay, I'm going to come here. I'm going to have my LED, and then I'm going to come over to my resistor, and then what am I going to assume? I'm going to assume what is the worst thing that could happen. The worst thing that could happen is this LED shorts itself out. For whatever reason, the LED becomes a short. If that LED becomes a short, then all the voltage is going to drop across the resistor. And in that case, the voltage drop across the resistor is 5 volts. That's the worst case. Under the worst case, what do I want to make sure? That I'm not drawing more than 8 milliamps. And so in that case, what would it be? V across the resistor is equal to the I times the resistance. Resistance is equal to VR, the voltage across the resistor, divided by I, which is equal to 5 divided by, what do we want? Never more than 0.008. And then what do we get? We get 5 divided by 0.008. And the right value of the resistor would be, the right value of that resistor would be 625 ohms. Okay? Now, there is not a 625 ohm resistance. Well, what if we went down to 330? Well, if I used a 330 ohm resistor, and if the voltage was shorted across the diode, what would I have? I would have all 5 volts. So I would have current, right? We've got V is equal to I times R. I is equal to V divided by R. And I've still got 5 volts. And then what if I used 330 ohm resistor, and then what if that diode had shorted out? Then what I would have is 5 divided by 330 is equal to 15 milliamps. That's 2x what is safe. 2x what is safe. What is likely to happen there? You're very likely that you could burn your LED out. Well, you say, well, I don't think the diode's going to short out. Yeah, but you see, look at this curve over here. Where are you operating? That diode is just a device waiting to draw huge amounts of current, right? What is the safe thing is, let's just put 0 volts across the diode. Okay, and then let's calculate all the voltage drop across the resistor, and that way, no matter what this diode does, there's no way that I am going to burn out my Arduino. Does that make sense? Well, what if you said, okay, well, let's come in and let's put this value. That value would be pretty safe, so let's design around that value. Well, in that case, you would say, let's say that's 1.5 volts. Well, if 1.5 volts is dropping across the diode, then what would we have? We would have 3.5 volts dropping across the resistor, and then we divide that by 0.008 milliamps, and what would we get? We would get 3.5 divided by 0.008, and then that's going to be 437 ohms. Well, if our typical resistors are coming as 220 ohms, 330 ohms, or 1000 ohms, okay, if they're coming like this, still, if we wanted 437, we still have to round to the 1000, because if we went down to 330 ohms, it would still then be possible to draw more than 8 milliamps from the Arduino. Man, I hope this isn't confusing you more, but what I want you to see is I don't want you to burn out the Arduino. So what is the safe thing to do? The safe thing to do is just say, I'm going to assume there's no voltage drop across the diode. All the voltage drop is across the resistor, and in that case, for 8 milliamps and 5 volts, I need a 625 ohm resistor. And if your box had a 625 ohm resistor, I would still advise you to put a little margin in, right? Put a little margin in, because what if your resistor isn't exactly the value that you thought? Maybe if instead of 625, maybe we would go 675 to be safe. But really, you don't have that level of fidelity in your resistors. And so I got a 330, I got 1000, I'm going to use 1000. Okay, and if I use 1000, I'm not going to burn it out. Now, if you go back to the Arduino R3, the safe number is probably 330 ohms. Okay, use 330, you're going to be safe. All right, so does that make sense what I'm saying? And that way, if different diodes behave a little bit differently, or the different color diode behaves a little differently, if you use 1000 ohms, you won't burn out your Arduino. Okay, and that's what I want you to do. So hopefully I haven't just bored you, and hopefully I haven't confused you. And what I would like is, I would like feedback from you guys, whether these supplemental lessons that I go in and put in the middle after I see where there's confusion, is that helpful or is it not helpful? Like, did I just annoy you with this lesson, or did I not annoy you? Okay, man, the other thing that kept coming up is in the discussion, there seemed to be an argument about the difference between building the circuit like this, okay, where the current limiting resistor was on the downside of the diode, or building it like this. Okay, and in that discussion, I saw some really bad physics about, oh, well, in this case, the diode is seeing the 5 volts, and in this case, the diode is not seeing the 5 volts. No. It's the voltage drop, okay? And the voltage drop across this resistor is exactly the same if you put it here or if you put it here. And if the voltage drop across that resistor is exactly the same, regardless of which side you put it on, then the voltage drop across the diode is going to be exactly the same, and the current is going to be exactly the same. So in both of these circuits, the voltage drop across the diodes are identical. The voltage drop across the resistors are identical. And the current through the circuit is identical. And so how do I decide which one of these to use? Well, just on my breadboard, what's more convenient? Sometimes it's easier to put the resistor on the downside because then you can connect the voltage to the long lead of the LED easier. Sometimes it's easier to put it on the other side. You can sort of put it on either side, okay? Now, the one exception to that would be when you are working with an RGB LED, right? The RGB LED looks like this, okay? And you have the 4 leads right off the RGB LED. They all come down here like this, and then they come down, and this is that long leg down here, and then you have the R leg, the G leg, and the B leg like this, the R, the G, and the B. In this case, you have to put the resistor on this side, because otherwise you would be sharing a resistor between the channels, and you can't do that because then you would be getting cross-channel, kind of like cross-channel communication, which wouldn't be good. The brightness that you set, the red LED would control how bright the green one was, or you change the green brightness and it also changes the red brightness. So when you are doing an RGB LED, you have to put the current limiting resistors on that side. You don't have a choice, okay? But still, what value should they be? They should be 1,000 ohms. And if they're 1,000 ohms, then not any one of your digital pins would be drawing more than 8 milliamps. Okay, guys, I really need feedback from you on this, because normally I just keep going, but I was just seeing that the way I'd explain things in lesson number 2, some people were getting confused, and so I hope this clears it up. But man, give me feedback. Quit the supplemental lessons, or when there seems to be confusion, give us a little bit more information. Okay, guys, I hope you enjoyed this lesson. This was just a quick one, and we'll get back now to our normal program schedule, and lesson number 3 will be next week as normal. I will talk to you, Paul McWhorter with TopTechBoy.com. I'll talk to you guys later.